in this video we're going to start section 2.4. In 2.3 we did a bunch of stuff with slope, and this section is more on slope. And we got three objectives: find the slope and equations of parallel and perpendicular lines. You should have seen that in geometry class also. Interpret slope as a rate of change, and find a function's average rate of change. That's a nice tie-in to calculus if that's the route you're planning on going. So two non-intersecting lines that lie in the same plane are parallel. If two lines do not intersect, the ratio of the vertical change to the horizontal change is the same for both lines. Or, you know, horizontal change over vertical change, that's just our slope, our rise over run. Because two parallel lines have the same steepness, they have the same slope. So a couple points here with slope and parallel lines. If the lines are parallel, then they have the same slope. And the converse is also true. If two distinct non-vertical lines have the same slope, then they must be parallel. And the last one sort of catches the undefined ones. Remember, if a line goes straight up and down, it has undefined slope. It is all rise and no run. So if you have two distinct vertical lines with undefined slopes, then they too are also parallel. All right, let's see what's going on in example 1 here. Write the equation of a line that passes through this point and is parallel to this line. Express the equation in point-slope form and then also in slope-intercept form. So we want to go through, that's an R, through negative 3 comma 1, and we want to be parallel to, P-A-R-A, parallel to this line, y equals 2x plus 1. Remember, to write the equation of a line, you need two things: a slope and a point. So let's see, we want to be parallel to this line, and this line has a slope of 2. So our line is going to have a slope of 2 since they're parallel. And we're going to need it to go through a point, and that point is 3 comma 1. That there is all the information we need. Okay, to put that into point-slope form, we use point-slope equation. Y minus y1 equals m times the quantity x minus x sub 1. Let's plug in our given information. Y minus y sub 1, well, our y value is 1. And that's equal to m, the slope, which we know is 2, times the quantity x minus this negative 3. If I minus a negative 3, the minus the negative will turn into a plus. So there is our point-slope form of the equation. Y minus 1 equals 2 times the quantity x plus 3. To get that down to slope-intercept form, we just have to solve for y. So step 1, we will distribute the 2. 2 times x is 2x. 2 times 3 is 6. Last step, add 1 to both sides. Well, this 6 plus 1 is going to turn into a 7. Y equals 2x plus 7. All right, now let's see what's going on graphically. Let's see, our given line was 2x minus 1, so we could graph that. Y-intercept of 1, slope of 2. So the blue line is our given line. Out here is the point 3 comma 1. We want to go through that line and be parallel to the first line. So again, the slope is rise 1, or rise 2, run 1. And if we kept that line going a little bit, you would see our y-intercept of positive 7. Okay, two lines that intersect at a right angle, 90 degrees, are said to be perpendicular, shown here in the figure 2.37. The relationship between the slopes of perpendicular lines is not as obvious as the relationship between parallel lines. The figure shows line AB, which has the slope c over d. So here the blue line is AB, and its slope, its rise and run, is they're just using letters c over d. So that's our rise up c and our run to the right d. Rotate the line AB counterclockwise 90 degrees to obtain this other line, A prime, B prime. So we rotated it counterclockwise 90 degrees. Now we have A prime, B prime. And where were we? And it is perpendicular to the given line AB. The figure indicates that the rise and run of the new line are reversed from the original line. The former rise, the new run, is now negative. This means that the slope of the new line is negative d over c. Notice that the product of the two slopes is -1. If I take the slope of the first line, CD, and multiply it by the slope of the perpendicular line, negative d over c, on the diagonal the c's would cancel, and the d's would cancel, leaving 1's, and then we'd still have this -1. This relationship holds for all perpendicular lines and is summarized in the box on the next slide. So, slope and perpendicular lines. And we have our if-then statement. If the lines are perpendicular, then the product of their slopes are -1. Or on the other side, if you have if the product of the slopes of two lines is -1, then the lines must be perpendicular. A horizontal line having 0 slope will be perpendicular to a vertical line having undefined slope. So again, here is 0 slope, here is undefined. If that's the case, they will be perpendicular. Now, what they have up here in the box is all good, but there's an easier way to think about perpendicular slope. An equivalent way of stating the relationship is to say that one line is perpendicular to another if the slope is the blank of the slope of the other line. Well, that would be the negative reciprocal. Or think about it this way. You're just going to turn it over and change the sign. If I give you the slope of one line is 3/4, that would be perpendicular to another line's slope. Just turn this fraction over and change the sign. It's 3/4, so I'm going to flip it to 4/3. This was positive, so I'll change this one to negative. Those are perpendicular slopes. Or let's say I have m sub 3, that slope is -7/8. If I want a perpendicular line, I would just turn this upside down. Now it's 8/7, and I'd change the sign from negative to positive. So those are perpendicular slopes. Let's try it out here in example 2. Two-parter, A and B, twice the fun. Part A, find the slope of any line that's perpendicular to this given line. Well, to find a perpendicular slope, we first got to know this line's slope. So for part A, we're going to start with x plus 4y minus 8 equals 0. The easiest way to find slope is to put this into slope-intercept form. So I want to get the y by itself. I'm going to minus x and plus 8 from each side. So now over here I have a minus 4y, or 4y. These are gone. I'm going to subtract x from this side. And these are gone. I'm going to add 8 to the other side. And now to get y alone, divide by 4. Remember, there is an implied 1 in front of that x. So here they're going to divide out. Y equals, I'm going to have -1 divided by 4, -1/4 x, plus divide 8 by 4, and you get 2. -1/4 x plus 2. And you know, I did find this number. This wasn't necessary. All we're really looking for is the slope. So I'm going to come back up here, this line. The m equals -1/4. So if I want to find the slope of any line that's going to be perpendicular to it, our answer here is going to be, turn that fraction over and change the sign. 1/4 becomes 4/1, or just 4, and since that was negative, this one will be positive. Okay, and what does part B say? Part B, write the equation of a line passing through this point that is perpendicular to the line from part A. Express the equation in general form. Okay, again, we need two things to write this equation of a line, slope and a point. We found the slope. We want it to be perpendicular to this slope, so our slope, m, is going to equal 4. And we want to go through the point 3, -5. And it does say express it in general form. Remember, general form is everything on the left and it's equal to 0, just like this. This is in general form. So we got to start somewhere, and that's going to be with point slope. Y minus the -5 equals m4 times the quantity x minus x sub 1, which in this case is 3. Okay, the minus the negative will turn to add the opposite. And we want to distribute the 4 and then get everything on one side of the equals. Y plus 5 equals, distribute the 4, 4x minus 12. And now I want to get everything on one side. I like to have my x first, and I like to have that positive. So I'm going to keep it over here. I'll keep the 4x. And now I want to get this y to the other side, so we're going to subtract it from both sides. Now it's minus y. And then I want to subtract 5 from each side. Minus 12 minus 5 more is negative 17. And that would be equal to 0. I'll put my equal to 0 on that side. And there is our general form, everything equal to 0. Okay, what's next? Practice time. So a couple practice problems for you to pause the video, try the problems, and then fire it back up and see if you got it right. Make sure you read the directions and you're answering the question that they have been asking.